Let's continue talking about nucleophiles, and also we're going to talk about electrophiles. So, nucleophiles and bases, we said before, that are electron-rich of some sort, electron-rich species. And here we have examples. Say that I have ethoxide. It's negatively charged. That's an electron-rich species. But we can also have another nucleophile. Ethanol can act as a nucleophile. Here we see lone pairs. But other species can also be nucleophilic. For example, say that I have this is a benzene ring, and I can have a species, an electrophile, so electron deficient, and we can have an attack by pi electrons. So here the nucleophile is pi electrons. So we have different types of nucleophile. We can have, for example, metal magnesium bromide. That's an example of a Grignard reagent. And here we say this bond is almost like a salt. We say that this is almost negative and this positive. So that is a nucleophilic carbon. So different examples of nucleophile. So, but we know that nucleophiles, what is important here to remember is that they attack on carbon on something different than hydrogen. If the electron-rich species attacks on a proton, then they're acting as base. And we gave an example. So, say that I have, let's say, let's do ethoxide again. And now ethoxide, we're going to put it simply in water. And thus, here we have the electron-rich, so arrows from the electrons to here to the proton. And you're going to form that conjugate acid and the conjugate base. Because these two pKa's are very close, this is actually an equilibrium. pK about 16, 15.7, but that is an acid-base reaction, right? Again, your electron-rich species, this here is attacking to get a proton. Here, if we have, let's do an example also with ethoxide here. We can have ethoxide acting as nucleophile. We saw here an example of ethoxide acting as a base in an acid-base reaction. Now let's do ethoxide at this time acting, say, attacking on an electrophile. This carbon right here is attached to a bromine, so this is partial positive. This makes this carbon electrophilic, and it can undergo a nucleophilic attack. So notice, same electron-rich species here is acting as nucleophile because it is attacking on a carbon, on an sp3 carbon. And here you have, in concerted fashion, the loss of leaving group. And your products are going to be, this is that. So that is an ether. So here, notice that I have my oxygen, 2 carbons, oxygen, 2 carbons, and 2 carbon atoms. And of course, bromide is your leaving group. Again, what I want you to notice is when you are on a problem, being a problem, is that be able to distinguish here when you have a nucleophilic attack, this case, over a carbon, or when you have here acting as a base in a proton transfer reaction. So that's very important. Now we're going to be discussing in another video what makes a good nucleophile and how do you do what are bases, so good, strong bases, strong nucleophiles, or weak bases, weak nucleophiles, and so on. We're going to be talking about that in another video.